Problem 3 states d plus 5c is equal to 3d minus 1. We're to solve for d. Now, what we are going to do to solve this problem is we first need to see if we need to run PEMDAS on either the left side of the equal sign or the right side of the equal sign. And that's not the case. Right? There's no opportunity to perform any of those operations. And then we need to combine like terms on the left side of the equal sign and the right side of the equal sign. But again, there's no opportunity to combine like terms. So now what we're going to do is we're going to move the terms with the d to the left side of the equal sign. And since we're solving for d, we need all of the other terms to be on the right side of the equal sign. So if we're considering each term, this d is in the correct side of the equal sign. This 5c is not. He needs to move. The 3d is not on the correct side of the equal sign, and the negative 1 is. So let's go ahead and start by moving the positive 3d. We can do that by subtracting 3d from both sides of the equal sign. And notice that I put the minus 3d below the d because these two terms are like terms. What we get is negative 2d plus 5c is equal to 0 minus 1. Now what we need to do is move the 5c to the right side of the equal sign. And to do that, we will subtract 5c from both sides of the equal sign. And notice here that I put the minus 5c off center of the negative 1. And that's because these two terms are not like terms. They don't have the same variable with the same power. So we cannot add them together. What we're going to get when we do that is negative 2d, because the 5c minus 5c is equal to 0. And on the right side of the equal sign, we're going to have negative 1 minus 5c. We're not finished yet, because the d on the left side needs to be positive and not have a number in front of it. So to get rid of the negative 2, we can divide by the number in front of the d. Divide by the negative 2 on both sides of the equal sign. So if we divide by negative 2 on the left side and we divide by negative 2 on the right side, what we'll end up with is negative divided by a negative is positive. 2 divided by 2 is 1 times d, which leaves us with just d is equal to this expression here on the right side. So minus 1 minus 5c over negative 2. Then I'm going to put a box around this, and that is my answer. Let's go ahead and look at number 4. And the first thing we want to do is see if we need to run PEMDAS on the left side of the equal sign or the right side of the equal sign. And there's no opportunities to do so. And then we look and see, do we need a combined like terms? And again, there are no like terms on the left side of the equal sign nor the right side of the equal sign. Alright. Third step is to get the terms with q, since we're solving for q, on the left side of the equal sign. We want all the other terms on the right side of the equal sign. So this term here has a q in it. He's on the correct side of the equal sign. The negative 18 does not have a q, so he needs to move. This term, qr, is on the wrong side of the equal sign. We need him on the left side of the equal sign. And the t is on the correct side of the equal sign. Again, we want all the terms with q on the left side of the equal sign and all the other terms without q on the right side. So let's start by adding 18 to both sides. I'll say plus 18, and I'm going to do plus 18 out here. And the reason why I put plus 18 way out here is because we don't want to add QR with 18 because they are not like terms. We don't want to add t with 18 because they are not like terms. Okay, let's rewrite our equation. We get 6q, and negative 18 plus 18 turns into 0. On the right side of the equal sign, we have qr plus t plus 18. Okay, so now we need to go ahead and move this term qr to the left side of the equal sign. And we can do that by subtracting qr from both sides of the equal sign. Notice here that I did not put qr underneath the 6q, and the reason is they don't have the same variable with the same powers, right? They do both have a q. However, this term here also has an r, right? So qr is not the same term as q. We cannot add these two guys together. All right, let's put a line underneath, and I'm going to write it 6q minus qr is equal to qr minus qr is 0. That leaves us with t plus 18. Alright, so now what we can do is on the left side of the equal sign, since both terms have a q, we can factor out that q. Alright, so the way that that's going to look is it's going to look like this. Q parentheses 6 minus r parentheses is equal to t plus 18. So factoring out the q is like a reverse distribution. Right? And you'll notice here in the q parentheses 6 minus r parentheses, if we distributed out the q, we would end up with our original expression, 6q minus qr. Okay, so now what we need is the left side of the equal sign to only have q all alone, and the right side of the equal sign to have all the other terms. So what we can do to get rid of this 6 minus r from the left side of the equal sign is we can divide both sides by 6 minus r. And so since we have a 6 minus r up on the numerator and we have a 6 minus r in the denominator of the term on the left side of the equal sign, they cancel out. That becomes 1 times q, which is just q. Okay. So I'm going to rewrite my equation over here. It's going to be q is equal to t plus 18 divided by 6 minus r. And that is my final answer. Put a box around that.